shared responsibility model. And then we will be talking about two security models, defense in depth and zero trust. We will move into looking at the concept of encryption and hashing. And finally, we will talk about some basic compliance concepts. Okay, so let's start with the shared responsibility model. This identifies the security tasks that are handled by the cloud provider or by the customer. Typically, when you are working on premises environments, you will have all your hardware, your operating system, your application, all managed and set up by you. That's why you will typically see on the slides everything that is listed for on-premises is managed by the customer. When you move your services into the cloud, things slightly change. Change depending on the kind of solution you are picking up. From the cloud environment, it may vary. For instance, if you look at infrastructure as a service, or in short, IaaS, typically in IaaS environment, you will have your cloud service provider managing everything that's in the hardware infrastructure, in terms of your physical hardware, because you are putting your services on Microsoft data center, and that data center is maintained and managed by Microsoft or your cloud service provider. So you don't have to worry about managing all the hardware aspects for things now. Things that you would have to manage on top of that would be anything that you install and implement. Typical example of an IaaS environment will be virtual machines. Now, within a virtual machine, you will not have to worry about all the hardware aspect, but your responsibility will start from choosing an operating system that you want to install and then managing it. And security patching, updating that operating system, and any other application that you install on top of that. Then we have also the PaaS, which is Platform as a Service. Within PaaS, you will have slight variation of things depending on the kind of solution you are picking up now. Within Azure, we offer a lot of different PaaS services to implement, and you can bring your own custom-built CRM or ARM systems. If you look at the diagram here in the slide, you can see everything including that was part of IaaS infrastructure as a service, and the operating system is now managed by, in this case, Microsoft. And there are a few things that are Microsoft. Look at the SaaS. The responsibility provider, in this case, is the responsibility of Microsoft. Yeah, that is, and that's want to implement the security across different areas. I will give you a simple analogy. Let's imagine together, you have an office environment and you want to secure it. You are just putting up a security guard outside the building. Do you think this is enough? What if somebody sneaks by that security guard and they can then walk around anywhere in the office? There, So we would like to implement security in all places, typically to get into the building. Maybe they need to use their smart card or some sort of ID to go through them. They cannot also jump onto from one floor to another. They will have to use their identity again. And once they are on the floor, they may not be able to go through all the doors. Every room must be locked too. We want to do something similar in our solution. Means we want to make sure that at every different stage we can challenge users or people that are trying to access our services. And they are trying to reach our data. For that reason, we use this layered approach. Now, within this approach, we will look at different areas that we can implement. When you start talking about physical aspects, we will look at all of your data. So, the data centers that we have and the people that come or try to get closer to your data centers, where your data lives. If I were to go to one of Microsoft data center as a Microsoft employee and just turn up without booking myself in for any particular reason, I would not be allowed to do that. And even if I do that, or even if I have a task to do, to complete, and I'm allowed to go there, they will not just let me go around anywhere in the environment. And they will be applying quite tight guidelines on what I can and cannot do. With security check on the perimeter, security cameras, and many other things to avoid anyone trying to sneak into one of Microsoft data centers. Go past the physical security. We talk about identity and access now. Physical identity checks would be looking at your identity card or any other sort of identity that you may write in the cloud environment. When you start looking at your solutions, you look at this as you providing and authenticating yourself on who you are. Before you are allowed to log into your services, typically you will use service like Microsoft Entra ID. In this case, Microsoft Entra ID will validate and apply access to your users. When you go down into looking at other layers in this model, like perimeter layer, this where we want to implement security to all the solution. So the data that is coming into your network can be filtered and assessed before it actually reaches your network environment. Kind of things that you would normally implement, like firewall, distributed denial of service attack protection, that's applied there. We will talk about some of these at a later stage within this course, but these are the kind of security that you want to implement for any packet that are moving throughout your network and prevent them from even reaching a network environment if they are not allowed or they shouldn't be traveling throughout your solution. Once into your network environment, we want to ensure that your network is secure in many different ways. One of the ways would be that you don't want to leave your network environment as one large network area. We would like to segment this network, and this is what we call subnetting. We subnet or subgroup the network environment just to ensure that we are not letting any packet of data loose within your entire network, and it's controlled into which network and subnet this data should travel into. In this case, if there was any corruption at any stage of your environment, or you have a malicious attack in a part of your network, it doesn't corrupt your entire network, but can be limited to a sub-part of your network. Now within this, we will talk about some security elements like NSGs or network security group. We can implement this to protect your network flow traffic between these subnets. Let's now move to the next layer, compute. This is where we look at your resources that you can implement in terms of resources in Azure, like virtual machines and any other compute resources. Typically, we would like to ensure that these services are controlled and the access to these services is only limited to people that are allowed to log in. So, control permissions on who is logging into these services and what they can do with these resources once they are logged into. The next layer would be application. There, we'll be talking all about applications and what type of applications we've got running. Are they up to date? Are they secured? And the kind of capabilities these applications have. Finally, let's talk about data. There, we have the information that we need for our environment or in our cloud. Typically, we want to make sure that this data is encrypted, no matter where it is in Azure, which means your data is encrypted at rest or at move when they are moving in the network. Data encryptions ensure that people can get access to data if they have managed to break into your data. They will not even understand what is inside this data because it will not be readable. Let's move on to talking about a different cybersecurity strategy. Now we are looking at CA, confidentiality, integrity, and availability. Now these three topics kind of form the foundation of security in all aspects. We want to make sure the data that we are working on or the projects that we are looking at are kept confidential for those who are allowed to look at them. For instance, if you are working with this data, you don't want anyone else to see this information, regardless of anything that is inside the data. It's sensitive or not, because you should be able to keep this data away from those who should not have been looking at this information at all. That means we want to make sure our information or data is kept confidential. In a work environment, you would want to allow permission to those who can look at this information rather than leaving it open for anyone on the network to explore this data or maybe exploit it if they want to. So, for that reason, we want to ensure that data that we have can be kept confidential. Now, there are different ways of doing it. You can apply permission on who can see this data. You can apply encryption to ensure that data can't be taken by people and open and explore it, and you can add other ways like password protection to some of these files, that way they cannot be opened by everyone. Now let's move on talking about integrity now. Integrity is making sure that we can rely on that data or that message that we have received, making sure it's in its correct form and it's not being amended, altered by someone either in transit or in store. Finally, we will talk about availability. This is referred to data being made available to those who should be working with it. For instance, if I have access to your project or file that I'm working on, I should be able to open that and work with it as and when it is appropriate for me to work with it. A lot of time we will see different malicious attacks happening where you no longer have access to your file or project, and this is where we want to ensure that we can eliminate that particular issue by making sure the services that are supposed to be available for you are made available for you when you want to access them. Now let's start talking about zero trust model. In nowadays, technology is changing and evolving very fast. We could agree on that. And because of these changes, attackers have the ability to sometimes bypass our conventional access and management solutions. We want to come up with a concept that can secure services in a way that they can be protected regardless of the new implementation and changes that have been brought into the environment. For this reason, we look at a model that is called Zero Trust Model, which simply implies one principle, which is trust no one and verify everything. This simply means that assume everything is kept as unprotected and in an open network environment. And you need to ensure that you can verify and test everything that's happening within the environment. You can do this by looking at the Zero Trust guiding principle. Starting with verify explicitly, we want to ensure that everything that's being used in the network environment or on your services can be verified and challenged at different stages to ensure that it's approved. Then we want to make sure we apply or provide least privileged access to users and services that are working in your environment. Okay. For instance, if you want to apply or raise some abilities to someone to do or carry out a task, we don't want to give them administrative access to complete or work with everything in that environment. We want to make sure we give them enough access so they can log in and do the task that they are required to do. For that particular reason, we talk about things like just enough access or looking at just-in-time access. For example, if I'm about to create something, I may request my rights to be elevated for a period of time. We want also to assume breach at all times. So have a mindset that your service can be reached at any time. For that reason, always analyze data and network traffic that you have within your environment, just to ensure that you are in control of everything that's happening. And if you need, you can implement any security solutions. Now, this approach should be extended to your entire digital state. And it's not just used as a philosophy, but also implemented as an end-to-end solution. And you can do this by using the 6 foundational pillars that we have in the Zero Trust model. In the first pillar, we look at identities, and we want to talk about users, devices, services, applications, all these identities that can be authenticated and challenged with stronger authentication. In the second pillar, we talk about devices. And this can be any device or any hardware that's within your network environment to make sure that we can assess them because they can create a large attack surface area. And we want to make sure that your environment or your setup has full visibility of all the hardware that's available within your network. In the application pillar, you want to make sure that you have the visibility of what application your organization use and also ensure that there are no shadow IT applications. These are referred to applications that are not permissible or unsanctioned applications that can be installed by users in a network environment. In the next pillar, we talk about data. Typically, your data should be labeled, classified, and encrypted wherever it is kept or when it is in transit. In infrastructure pillar, we focus on your infrastructure. This could be your cloud services, your on-premises environment, or something that you have that is implemented in a hybrid environment, and that should be all monitored as well. Finally, in the last pillar, we talk about network. We need to make sure your network is segmented and you are able to control the different segments or different subnets within your network environment in real time and monitor this data. Now, let's look at the encryption. One way to mitigate cybersecurity threats is to look at encryption. Encryption typically allows you to take your data that is in read format and convert it into non-readable formats for those who should not have access to it. So if they were to grab this data, either where it is stored or on transit, they should not be able to look at this data and understand anything out of it. And for those who should have access, they should be able to use some sort of method to convert this information or unreadable data back into readable format. This is the process of encryption and decryption of the data. Typically, we have two different formats that we use within encryption. And depending on the need, we will use different type of encryption. Now let's have a look at symmetric encryption type and understand how that's different and when it can be used. For example, if you look at the picture on the slide where you can see symmetric encryption, you can see I can have something that is plain text, and I want to ensure that this plain text is converted into encrypted file or encrypted data. And it becomes non-readable. Now, to do this, typically you will need to use a key. With this key and an algorithm that you are using in the back, you will be able to convert this simple plain text into a non-readable format. Once this data is converted or encrypted, anyone that gets access to this data will not be able to read or get the information that is within this file without using this same key. From the other side, with the asymmetric encryption, you are using two different keys or a pair of keys. One of them called a private key, which you keep private to yourself, you don't share it. The second one is called a public key that you can make available to public. This later you should share to anyone over the internet or using your website, for example. And it will be available for people to use it and communicate with you. For instance, I'm using my private key and I'm encrypting a particular file that I want to share out with people. I can make this file available, let's say, on my website. Or I can send it to someone over the email, and for them to be able to see this file, they will need to download my public key that I made available for everyone and decrypt that file or data. This will ensure the integrity of the SIA model. Remember it? We spoke about it earlier. I can be assured that this file can only come from that particular person that encrypted this file with private key. In the same way, if somebody else wants to send me a file, they can use my public key and encrypt the document and send it back. This ensures that this data cannot be picked up by anybody else and decrypted and understand it. I will be the only one able to decrypt it, and with using my private key that I didn't share with anyone. Both of these mechanisms have their own users that they use this solution. With symmetric, you could use it, for example, with banking and other app. With asymmetric encryption, you can use it as a digital signature, and also can be implemented with certificates and your HTTPS type of traffic, which is secured using transport layer security, and they use this method for encryption using asymmetric keys. Now let's talk about hashing. Now, hashing may sound very similar to encryption, but obviously it comes with slightly difference. Now, with hashing, we are going to look at a plain text again. Now, what we are trying to do with this plain text is we are converting it into a non-readable format. Again, sure, it sounds very similar to encryption, but we'll talk about how it is not encryption. With hashing, we will use an algorithm, in this case known as the hashing algorithm, which is typically a fixed size key that we are going to use. Typically, these can be anywhere between 128 bits to 256 bits, and they keep getting stronger and stronger. And for example, 512 bits is really strong. These are strong encryption keys or algorithms that you can use because they are utilizing that main number of bits to increase the security. This hashing algorithm is going to be used to convert your original text into a non-readable format. For users that are going to pick up this file that was hashed, they cannot understand any information. The key difference between this and encryption is that you cannot convert this file back into a readable format. Hashing is not designed to convert it back into the original readable format. Just like encryption, you do encryption and decryption. We don't do that with hashing. The whole concept of hashing is that you should be able to use that hash value to check against a pre-stored hash value to ensure the two values matches. You know then that the value and the original message that was used to hash this data would not have been distinct. You should also note that hashed products would be always a fixed value because you are using a fixed number of bits. This fixed number of bits, you are going to use them to hash the output of your data. The result will always be in a fixed value type, no matter if your input is a word, sentence, a file, a whole document. The hashing of this would be always a fixed value. Hashing can be used or has been used for services that allow to verify passwords. So you can take the hash value and store them on your servers every time somebody authenticates. You can convert their password into hash and then verify the hash value with the stored one. Confirm if somebody has typed in the correct password. This prevents users from revealing their password out to the public or over the network or internet. However, this doesn't stop malicious actors trying to exploit this particular method to get into your services. They will just try to use different random inputs as plain text and convert them into a hash value. And these hash values that they are going to use then can be mapped to the hash value that you have. And if they got too much of these values, they can reverse engineer to understand what was the initial input. Now, to prevent this from happening, what we can do is introduce something known as certified hashing, which means we can also add something else as another fixed value to this particular hash algorithm to make it more difficult for these malicious actors to work their way backward. Typically, you can see like timestamp values and other similar values added to this just to ensure that if somebody was to try this at a different time period, this value will not match. And in return, you will have a hash value that's got combination of your word and a stamp or something else that can then be looked at as a final product. Reverse engineering in that case may be much more difficult for malicious actors to work out and can take them much longer to break your hashed value. Reverse engineering in that case may be much more difficult for malicious actors to work out and can take them much longer to break your hashed value. Now let's look at governance, risk, and compliance concept, or GRC in short. A structured approach for managing GRS helps organizations reduce risk and improve compliance effectiveness. An important prerequisite to establishing GRS competency is understanding the key terms. First, governance. Governance is the system of rules, practices, and processes an organization uses to direct and control its activities. Many governance activities arise from external standards, obligations, and expectations. For example, organizations establish rules and process that defines the who, what, where, and when users and applications can access corporate resources and who has administrative privileges and for how long. Second, risk. Risk management is the process of identifying, assessing, and responding to threats or events that can impact company or customer objectives. Organizations face risk from both external and internal resources. External risk can come from political and economic forces, weather-related events, pandemics, and security breaches, to name just few of sources that could be. Internal risks are risks that come from within the organization itself. Examples include leaks of sensitive data, intellectual property thefts, fraud, and insider trading. Third, compliance. Compliance refers to the country, region, state, or federal laws, or even multinational regulation that an organization must follow. This regulation defines what type of data must be protected, what processes are required under the legislation, and what penalties are issued to organizations that fail to comply. It's important to note that compliance is not the same as security, but security should be considered when building a compliance plan, as effective security is frequently a compliance requirement. Compliance requires only that the legally mandated minimum standards are met, whereas data security covers all the processes, procedures, and technologies that define how you look after sensitive data and guard against breaches. Some other compliance-related concepts include data residency, data sovereignty, and data privacy. When it comes to compliance, data residency regulation governs the physical location where data can be stored and how and when it can be transferred, processed, or accessed internationally. These regulations can differ significantly depending on jurisdiction. Another important consideration is data sovereignty. That concept that data, particularly personal data, is subject to the laws and regulation of the country, region in which it's physically collected, held, or processed. This can add a layer of complexity when it comes to compliance, because the same piece of data can be collected in one location, stored in another, and processed in still another place, making it subject to laws from different countries and regions. Then, data privacy. Data privacy is all about providing notice and being transparent about the collection, processing, use, and sharing of personal data. These are fundamental principles of privacy, laws, and regulations. Personal data means any information relating to an identified or identifiable natural person. Privacy laws encompass any data that is directly linked or indirectly linkable back to a person. Organizations are subject to and must operate consistently with a multitude of laws, regulations, codes of conduct, industry-specific standards, and compliance standards governing data privacy. Now let's start with lesson 2. In this lesson, we will talk about concepts of identity and start talking about some of the terminologies like authentication, authorization, and we will look at identity as a security parameter, discussing what identity services or identity-related services are. Let's make a start where we're going just to start talking about two concepts, authentication and authorization. Surely, the two terms are very simple to understand and commonly used. And typically, when we talk about authentication and authorization, people generally know what you are talking about, but it's important to make sure you can differentiate between them. Authentication, also known as auth-n, is simply a process of somebody authenticating on who they say they are. So if you are trying to log into a service, that service should be able to identify who you are before they can let you in. Once you authenticate yourself, you may be granted access now. This is where the second part starts, which is authorization. Authorization, also sometimes referred to auth-z, simply allow you a level of access to a service, what you should be permitted. Once you authenticated yourself, we will apply that. For instance, I tried to log into a database. I would be challenged by authentication to ensure I'm allowed to log into that database with my username, my password, to ensure I'm the correct person. Once I logged in, I may then be authorized to only look at parts of that database and maybe just be able to read that information that's on that database, and I'm not allowed to modify anything. So that's where the limitation of my authorization. Typically, identity has always been referred to as something that's limited within the boundaries of your on-prem environment and used as an aspect to identify a user. Now, that has changed. With modern advancement, we can now use identity as a perimetered security simply because other services are no longer confined to your on-prem environment. With users bringing their own devices and new connection to services that are kept in cloud across the globe, it is making it difficult for on-prem security to use just the conventional way of working with things. Hence, use identity as a security measure to understand the perimeter of your solution. Now with identity, we are no longer limited to just user as an individual that can be considered as an identity. You can use applications and assign them identities. It can be any other services or devices that you can be using, for example, an IoT that may be implemented in your environment. To manage some of this, we will fall back onto the 4 pillars of your identity infrastructure. We discussed already authentication and authorization, which simply ensure that you know who someone is when they are trying to log in, and in this case, a service or a user or an application that is trying to authenticate itself so they can be allowed access. Authorization would be what level of access are they granted or allowed when they carry on working and using the service. Now, apart from these two, we do have two more areas. One of them is auditing. Any network administrator would like to audit the identity or audit services that are within your environment. You want to ensure you can understand all sorts of different types of data around identity. Who's logged in? When did they log in? What did they do when they log in? What did they change? And also the different data that may be around that identity. So it's important that you can or you are able to audit as and when required to understand or secure your environment. Now, along with this, we do want to talk about one important aspect that is called administration. You want to ensure that you can administer your identity, for example, who has created them, why was it created, why is it updated, and all the changes can be brought to any identities of a service. Now let's have a look at modern authentication. Modern authentication is an umbrella term of authentication and authorization methods. These methods are between the client, for example, a laptop or phone, and the server, like a website or an application. At the center of modern authentication is the role of the identity provider. An identity provider creates, maintains, and manages identity information while offering authentication, authorization, and auditing services. With modern authentication, all services, including all authentication services, are supplied by central identity provider. Information that's used to authenticate the user with the server is stored and managed centrally by the identity provider. With a central identity provider, organizations can establish authentication and authorization policies. They can monitor user behavior, identify suspicious activity, and reduce malicious attacks. Another fundamental capability of an identity provider and modern authentication is the support of single sign-on. With SSO, or single sign-on, the user logs in once and that credential is used to access multiple applications or resources. When you set up SSO between multiple identity providers, it's called federation. We'll talk about the concept of federation later on. Now, Microsoft Entra ID is a very good example of a cloud identity provider service that we have at that. Also, we are going to talk about it in the next module. In the context of computer network, a directory is a hierarchical structure that stores information about objects on the network. A directory service stores directory data and makes it available to network users, administrators, services, and applications. Active Directory, AD, is a set of directory services developed by Microsoft as part of Windows 2000. It was developed for on-premises, domain-based network. The best known service of this kind is Active Directory Domain Service, ADDS. It stores information about members of the domain, including devices, users, and verify their credentials, and define the access rights that they have. A server running ADDS is a domain controller. ADDS is a central component in organization with on-prem IT infrastructure. ADDS gives organization the ability to manage multiple on-prem infrastructure components and systems using a single identity per user. ADDS doesn't, however, natively support mobile devices, SaaS applications, or line of business app that require modern authentication method. The growth of cloud services, SaaS applications, and personal devices being used at work has resulted in the need of modern authentication and an evolution of Active Directory-based identity solution. Microsoft Entra ID, previously referred to as Azure Active Directory, is the next evolution of identity and access management solutions. It provides organization with an identity as a service, or ADAS, solution for all their apps across cloud and on-prem environment. In this course, we'll focus on Microsoft Entra ID, a solution within the Microsoft Entra family of products, and Microsoft Cloud-based identity provider. Okay. Now, let's talk about concepts of federation services. Now, what happens if you are trying to access services that are not just limited to your environment, and you want to access these services from other environments? Let's take a very quick example I have in this slide that you could see. So I have a domain A. Imagine this is one environment, and I have an identity provider for domain A, which can authenticate any service that's running within this identity provider. Now we have a website running within domain A. This website has a trust relationship built with its identity provider, so it knows anything that's within its environment. We also have domain B. This is a separate environment which has its own identity provider that can authenticate all the services within that domain. We also have a user that sits within domain B that has authenticated itself to identity provider B. Now, if these users try to connect to this website, which is a completely different environment, using a completely different domain, what typically will happen, this user access request is simply forwarded back by the website to the identity provider. Or the identity provider that the website trusts eventually. In this case, this is identity provider A, which may not have any details about that particular user, and it will not be able to authenticate the user directly. What it can do, it looks at any information like the user details that you provide to authenticate. In this case, let's assume we have john@contoso.com. The identity provider look at details like contoso.com and see if it understands or can find that service in its directory. Now, in this particular example, we have trust relationship built between identity provider A and identity provider B. And again, it's important to understand that this trust relationship doesn't have to be bidirectional. In this case, we see it in the picture, it's in one direction. Now let's assume that identity provider B is contoso.com. My identity provider A will know that it understands where identity provider B exists. So what it will happen, it's going to forward this information back and bounce it through the user to identify itself with provider B to ensure that it can authenticate the user. Because that user already has a relationship built with that identity provider B, it will simply generate a token to say, yes, I know this user, let this user in. Once it's happy with that, the identity provider A will send a token back to the website saying, yes, we can allow this user in, and it will allow it to access the service. In this session, we learned about security and compliance concepts, and we talked about shared responsibility model, defense in depth, SEA, as cybersecurity strategies. In addition, we learned the zero trust model, encryption, hashing, and then we looked at our identity concept, discussing the difference between authentication and authorization, and we described identity-related services. This concluded session 1. We will take a quick 10-minute break, and we will be back in session 2 to talk about capabilities of Microsoft Entra ID. See you shortly. Welcome back from the break. I hope you had enough time to drink water, to move your legs, and to get ready for this session. In session 2, we will explore the services and identity types of Microsoft Entra ID, along with the capabilities of Microsoft Entra ID, including authentication, access management, and identity protection and governance. So let's start. This session is broken into 4 lessons. We will start looking at the function and identity types of Microsoft Entra ID. Then, moving on to the authentication capabilities of Microsoft Entra ID, followed by access management capabilities of Microsoft Entra ID. Finally, we will be talking about identity protection and governance capabilities of Microsoft Entra. So let's start with the first lesson, looking at functions and identity types of Microsoft Entra ID. So this lesson will talk about what is Microsoft Entra ID and talk about different types of identities we have in Microsoft Entra ID. Microsoft Entra ID, formerly named Azure Active Directory, is Microsoft's cloud-based identity and access management services. Organizations use Microsoft Entra ID to enable their employees, guests, and others to sign in and access to the resource they need. It provides a single identity system for multi-cloud and on-prem applications. This can help you meet your governance requirement. Now, if you already have any of these products in your organization, things like Microsoft Office 365, Dynamics 365, the Azure portal, and any SaaS application used by your organization, then you automatically have Microsoft Entra ID tenants running in the background. Microsoft Entra ID include Identity Secure Score. This helps you to objectively measure your identity secure posture, plan identity security improvement, and review the success of your improvement. Now let's talk about some basic terminology that we will be using in this presentation. First, tenant. A Microsoft Entra ID tenant is an instance of Microsoft Entra in which information about a single organization resides, including organizational objects such as users, group, devices, and application registrations. Then we have directory. The term Microsoft Entra ID directory and Microsoft Entra ID tenant are often used interchangeably. When you ask the question to what can I assign an identity in Microsoft Entra ID, there are 3 categories: human, workload, and devices. Let's first start with people, human identities. Examples of identities assigned to people are employees of an organization that are typically configured as internal users and external users that include customers, consultants, vendors, and partners. For our purposes, we will refer to this as user identities. The second category of users that you can assign identities to are software-based objects, such as applications, virtual machine services, container, or other. These identities are referred to as workload identities. Workload identities enables the software workload to authenticate and access other services and resources in Microsoft Entra. In Microsoft Entra ID, workload identities are service principals and managed identities. A service principal is essentially an identity for an application that delegates its identity access functions to Microsoft Entra ID, while managed identities are type of service principals that are automatically managed in Microsoft Entra ID and eliminate the need for developers to manage credentials. The third category of users are that you can assign identity is to physical devices, such as mobile phone, desktop computers, IoT devices, or any other devices. Device identities can be set up in different ways in Microsoft Entra ID. We have the Microsoft Entra ID registered devices. This provides users with the support for bring your own device or mobile device scenarios. We have Microsoft Entra ID joined devices. This represents a device joined to Microsoft Entra ID through an organizational account. And lastly, the hybrid Microsoft Entra ID joined devices. These devices are joined to your on-prem Active Directory and Microsoft Entra ID, requiring an organizational account to sign into the device. Many organizations are a mixture of both cloud and on-prem applications. Microsoft Identity solutions span on-prem and cloud-based capabilities. These solutions create a common user identity for authentication and also authorization to all resources, regardless of location, and we call this hybrid identity. Hybrid identity is accomplished through provisioning and synchronization. Now, the inter-directory provisioning is provisioning an identity between two different directory services systems. For a hybrid environment, the most common scenario for inter-directory provisioning is when a user already in Active Directory is provisioned into Microsoft Entra ID. The synchronization is responsible for making sure identity information for your on-prem users and groups is matching the cloud. One of the available methods for accomplishing inter-directory provisioning and synchronization is through Microsoft Entra ID Connect Cloud Sync. Microsoft Entra ID Connect Cloud Sync is designed to meet and accomplish your hybrid identity goals for the provisioning and synchronization of users, group, and contacts to Microsoft Entra ID. Now let's have a look at Microsoft Entra ID and look at users' settings. So first of all, we have to log on to admin.microsoft.com. Once we are in admin.microsoft.com, we have this menu. We are going to access to identity. Once we access to identity, it's going to redirect us to Microsoft Entra. I'm going to log on with my account to Microsoft Entra. I would be able also to access it directly from intra.microsoft.com. Once I'm on it, I have the identity section, and currently I'm interested in users. So in the users, we have all users, we have the deleted users, and we have user settings. So let's select all users. In here, I will be able to see all the users that I have in my directory or in my tenant. Let's select, for example, Adele Vance. So once I selected Adele Vance, I could see the picture of Adele Vance. I could see also the email that she is using to log in to this platform or to the portal. I have also the object ID. I have the user type. I could see the group membership, application, assigned rules, and also the assigned license. I have the monitoring section where I could see the user sign in. So I have 0 sign in for the latest period. I could go also to properties where I have more information related to Adele, job, contact information, email, and more information like here we have department, employee ID, the manager, and the office location. Now, I could come from here. I have also other monitoring information. I could see the assigned rules, clicking right to assign rules, and I could see that Adele has two rules related to user administrator. So Adele is a user administrator to the administrative unit Japan and also to the administrative unit France. I could add other assignment to Adele if I want to, for example, application administrator, and remember that this is rules related to Microsoft Intra ID. I have the administrative units in here where I could assign Adele to an administrative unit. We see that it does exist in France administrative units. I could go also to groups. I see all the groups that Adele is member on it. I could add also other membership. So I have just opened the groups. I have the list of the groups. I could select one group, for example, SEO connection, and then I will be able to assign it to Adele and add a membership to this group. Also, we have licenses. I see that Adele has already 3 licenses, and I could assign more licenses if I want. So I have just to select the license, and once I select the right license, I assign it to Adele. We have in here devices where I could check if there is any devices registered in the name of Adele. So there is no devices registered with Adele name. I have also Azure rule assignment, and this is related to airbag, to the rules that are given to Adele related to Azure resources, as we explain it in the course. That's it. Now let's move to the second lesson of this course, looking at the authentication capabilities of Microsoft Intra. Now within this lesson, we will talk about authentication methods, and we will look at multi-factor authentication and password protection and management capabilities of Microsoft Intra ID. Let's have a look at the authentication methods now. Passwords has been a primary method of authentication for a very long time, and we still use this as one of the forms of authentication. However, they have many problems, especially if used in a single-factor authentication, where only one form of authentication is used. If they are easy enough to remember, they are easy for a hacker to compromise. Strong passwords that aren't easily hacked are difficult to remember and affect user productivity when forgotten. What we can do now? You can use secondary methods to allow you to authenticate yourself to different services by using a device that you may hold with you, like your phone, using a phone call and an SMS to validate. Could be a better way? Sure. We do have a better option, and we have other options that are considered even better than using your personal device. Things like using open protocols that can allow you to connect to services using Microsoft Authenticator app that can allow you to authenticate yourself every time you log into a secure site or a service. Also, we have a better ways than all of this. To log in into some of your services and authenticate yourself, you could use also passwordless features. We have Windows Hello that allow you to log into your devices and authenticate you on your local device as you log in. Now sometimes I get asked, why do you think this is the best method to log in or authenticate yourself? Simply because this service authenticates me with my local device by using my facial recognition, and once it logs me in, it doesn't ask me for any authentication. User password, I will not be using them for services that are associated to my account. Also, you could still use Authenticator app to log into without using your password. You can use your fingerprint or facial recognition on this app, and they can authenticate your access, which can be a secondary form of authentication on some of these. Finally, use fast identity online services or certificate-based authentication could be a solution that you could use. Now let's talk about multi-factor authentication. You could also use multi-factor authentication along with your services. We did mention different authentication methods. Some of those were primary and secondary methods. Here we are talking about multi-factor authentication. We want to use more than one way of authenticating ourselves just to make sure that the user that's trying to log in is challenged enough to ensure as they are who they say they are. To do this, we use multi-factor authentication. Now, multi-factor authentication relies on three main areas. One of them talks about something you know. And typically, this is what we spoke about in terms of passwords, PIN, or memorable words that you are aware of. Apart from that, you would also want to have an understanding of something they could have. And here we spoke about having a mobile device or smart card. Finally, we want to ensure that we have something that they are. Basically, this is identifying an individual using their biometrics. Could be a voice recognition or facial recognition. So putting those together in a mix will ensure that we have challenged strongly users that are trying to look into a service. Password protection. Password protection is a feature of Microsoft Entra ID that reduces the risk of users setting weak passwords. Microsoft Entra Password Protection detects and block known weak passwords and their variants, and can also block other weak terms that are specific to your organization. Default global banned password lists with known weak passwords and their variations are automatically applied to all users in a Microsoft Entra ID tenant. You can define entries in a custom banned password list to add organizational specific terms such as your brand name or product names. When users change or reset their passwords, these lists are checked to enforce the use of strong passwords. Microsoft Entra Password Protection helps you defend against password spray attacks. Microsoft do this protection based on real-world security telemetry data from Microsoft Entra ID, which is used to build the global banned password list. For hybrid security, admins can integrate Microsoft Entra Password Protection within an on-prem Active Directory environment. Now, let's go back onto Microsoft Entra ID and have a demo. Now talking about authentication method and MFA. So again, we are going to log into the entra.microsoft.com, and here we have the section protection. In the section protection, we are interested into the authentication methods. And here it provides me with the list of the authentication method existing in Entra. So I'm going to select SMS, and it's giving me information related to the SMS saying this authentication method delivers a one-time code via SMS to user's phone, and the user then input that code to sign in. SMS is usable for multi-factor authentication and also self-service password reset, and it can be also configured to be used as a first factor. I could enable this, and then I will target the users or the group. So I could target all the users, and also I could decide to exclude a group of users from using this feature. Let's get back. We have also the voice call that I could select it. We have also the information saying this method places a phone call to a user, which the user must then approve using the telephone keypad. And then it's saying that it's not usable as a first factor authentication method, not like the SMS. Same to same, I could enable it, include user and exclude user, and also both of them has this configuration section where I could configure phone options. Now we have also the Microsoft Authenticator, where in the Microsoft Authenticator, when I enable it, I could include user and exclude users too. I could configure it, and here it gives me the information that Microsoft Authenticator app is flagship authentication method usable in passwordless or simple push notification approvals mode, and the app is free to download, and we could use it with Android, iOS, mobile devices. Fair enough. We could see also other possibilities. So we have FIDO, we have hardware token, we have email OTP, etc. So we have all the possible ways. We have also the password protection in here, where you could custom smart lockout, and you could fix the lockout threshold, where here it's fixed to a 10 attempt before locking out the account, and also we have the lockout duration that you could fix. You could also establish the custom bind password, and you have just to put the list in this section. Then you could enable password protection in Windows Server Active Directory if you want to. We have two modes, so we have enforced or the audit. For the enforced, is going to oblige the user to not using a password from the banned password list, while the audit is going just to put a log even after allowing the user to use that banned password. It's going to have only the audit, while enforced we have the audit and we are going to block that activity. Moreover, so we have here the monitoring section, and in the monitor section we have the activity. So we could look into the activity. We have the registration. I could see the user registered by authentication method. I could see recent registration by authentication method. I could, in the usage too, having graphs that could give me all the information. Here I could see the sign in by authentication method. So I see that there is 3 in total with password. I could see also the sign in by authentication requirement, so I see it in a graph. I could configure a filter if I want to do so. I have also other graphs like password reset by authentication, number of password change and reset too, that I could see in this section. Now we are interested also to the multi-factor authentication, so I'm going to click to show more. And I have the multi-factor authentication in here. So here I have information, Azure multi-factor authentication, and it's going to tell me, give me links to documentation where I could learn more about this methodology used in Azure. I could go to the account lockout. So same to same, I could set number of multi-factor authentication denials to trigger account lockout. The minute until the account lookout is going to reset the counter, and also the minute until the account is automatically unblocked. I could block or unblock user if I want to. So from here, I could add a user and the reason why I wanted to block it, and that user will be blocked and will not be able to to connect until we unblock it or after remaining for 90 days. Then we have also fraud alert that allows user to report fraud if they receive a 2-step verification request. that they didn't initiate, so we could activate it and enable it in here, and the user will be able to submit this fraud alert. We have the notification section where I could put the email of the administrator to receive this fraud alert. And we have also other configuration that I could do in the multi-factor authentication that I advise you to look at it in the documentation. Now let's move to the second lesson. Here we are going to explore access management capabilities of Microsoft Intra. Now within this module, we will talk more about conditional access and its benefits, and we will look at what are Microsoft Intra rules and how they differ from role-based access control, or in short, RBAC. Let's start talking about conditional access. What is conditional access now? If you consider the word conditional access, maybe it tells you that it is giving someone access based on some conditions. And that's exactly right. We are talking about allowing people access based on their different conditions. In this case, we will talk about something referred as signals. Conditional access policies are if-then statement. For example, a conditional access policy may state that if a user belongs to a certain group, then they are required to provide multi-factor authentication. A conditional access policy in Microsoft Intra ID consists of two components, assignment and access controls. With the assignment, admins can determine which signals to use. The assignment portion of the policy controls the who, what, where, and when the conditional access policy is applied. If you have more than one assignment configured, all assignments must be satisfied to trigger a policy. You could look at some of the assignments in the slides if you want to. When the conditional access policy has been applied, an informed decision is reached on whether to block access, grant access, or grant access with extra verification, or applying a session control to enable limited experience. Let's have a look at Microsoft Intra rules and rule-based access control. Microsoft Intra rules control permissions to manage Microsoft Intra resources. For example, allowing user accounts to be created or billing information to be viewed. Microsoft Intra supports built-in and custom rules. There are many built-in rules for different areas of responsibility. All built-in rules are pre-configured bundles of permission designed for specific tasks. A few of the most common built-in rules are Global Administrator, User Administrator, and Billing Administrator. However, if you are not happy with the long list of the built-in rules, you can create your own rules, which we refer as custom rules. Also for Microsoft 365 services, Microsoft Intra has added some service-specific built-in rules, each of which grants administrative access to Microsoft 365 services. This means that Microsoft Intra built-in rules differ in where they can be used. There are three broad categories. The first, Microsoft Intra specific rules. These rules grant permissions to manage resources within Microsoft Intra only. Second, service-specific rules that grant permissions to manage features within the service like Exchange Administrator and SharePoint Administrator maybe. Third, we have the cross-service rules. These rules span services. For example, Microsoft Intra has security-related rules, like Security Administrator, that grant access across multiple security services within Microsoft 365. Now, please remember, we spoke about Zero Trust in Module 1. We want to always ensure that we allow least access or privilege to users in all environments. So not just to make user administrators if they need to carry out a small task. Provide them with a rule that gives them access to handle only their task. Now, apart from talking about Microsoft Intra ID rules, we wanted to talk about rule-based access control. Now, what is the difference between the two? Microsoft Intra rules control access to Microsoft Intra resources, such as users, group, and applications, while Azure rules control access to Azure resources such as virtual machine, storage, and this using Azure Resource Manager. Okay, let's have a demo and look at conditional access. So for the conditional access, now we are going also to log on to intra.microsoft.com. We go to protection, and then we go to the conditional access. Now in here, we have the possibility to create a new policy or create a policy from a template. So let's create a new policy for conditional access. So in here, you give a name of the policy, for example, my policy. And then remember, we said that the policies are if-then statement, so the assignment will be containing all the if, and the access control will be containing the then, which is what is going to happen if the assignment is true. So first of all, I have users and group, and in here I could include all the users. I could select users and group, either guest or external users, directory rules, users and groups, and in here it's going to redirect me to all the users and group to select one of a group of them. We have also the exclude, where you could exclude from applying this policy to guest, directory, or users and groups. We have target and resources, and in target and resources you could select policy to apply to cloud app, to user actions, or to authentication context. So let's assume we're choosing cloud apps, and in here we have to include all cloud app, for example, or select an app, and here I could put a filter, or I could select from the list of cloud app one or more cloud app, for example, Office 365 and other storage, and I will be selecting them. If I select all the cloud app, I could possibly exclude some of them by selecting from here some cloud app. Then we have conditions. So you could select conditions, and I will have the long list. So I have the user risk, sign-in risk, device platform, location, client app, and filter for devices. So in the user risk, I could see that I have 3 levels of risk. So I have high, medium, and low that I could choose from to enforce my policy. I have the sign-in risk, same to same. So I have 4 levels, high, medium, low, and no risk. And remember, it says that this risk level is generated based on all the real-time risk detections that has done by Microsoft. We have device platform. I could select some device platform, including Android, iOS, Windows Phone, Windows, macOS, or Linux. I could also exclude devices if I want to enable it for all of them except a group of devices. We have also location that is going to be based on IP. So I could in here configure it and then I put all trusted location, or I could select location, and in here is going to redirect me to multi-factor authentication trusted IP ranges. Client app, in here I could check from where my user has connected, from the browser, the mobile app, from Exchange, Active Sync client, or other client. I could do filter for devices, so in here I could put a property like display name, manufacturer, and then I have operator, is it equal, start with, contains, and then I put a value according to the syntax that I want to put. And also I could add other expression and choose to put an AND or OR connection between these expressions. Then I finished with the if. I go to the then, and in the then I have the decision, either block access or grant access. And when I grant access, I could decide to require multi-factor authentication or require authentication strength. I could also decide to require password change, or I could decide to require approved client app or Microsoft Intra Hybrid joint devices to validate this connection. Then I have the session section, where I could decide to either put in control access based on the session control to enable this limited experience within this cloud application. Once I prepared my if-then decision, I could enable my policy while putting it in on, and I will be able to create my policy, and I will start using it from this point. Now, let's look at lesson number 4. In this lesson, we are going to talk about identity governance capabilities in Microsoft Intra. Now, within this lesson, we will talk about identity governance in Microsoft Intra, and we will talk about what is access reviews and privileged identity management. And finally, talk about the capabilities of Microsoft Intra identity protection and permission management. When you are administrator that manage identities in a company, many questions might come into your mind. Which users should have access to which resources? What are those users doing with that access? Are there effective organizational control for managing access? Can auditors verify that the controls are working? To address these key questions, Microsoft Intra Identity Governance gives organizations the ability to govern the identity lifecycle. Also, govern access lifecycle and secure privileged access for administration. Let's start understanding the identity lifecycle. Managing users' identity lifecycle is at the heart of identity governance. When planning identity lifecycle management for employees, many organizations, for example, use the join, move, and leave process. When an individual first joins an organization, a new digital identity is created if one isn't already available. Then, when an individual moves between organization boundaries, more access authorization may need to be added or removed to their digital identity. In addition, when an individual leaves access, may need to be removed, and the identity may no longer be required. On the other hand, access lifecycle is the process of managing access through the user's organizational life. Users require different levels of access from the point at which they join an organization to when they leave it. At various stages in between, they will need access right to different resources depending on their role and their responsibilities. Finally, privileged access life cycle. When employees are assigned administrative rights, there should be a governance process because of the potential for misuse. We also have access reviews. Access reviews in Microsoft Intra ID enable organizations to efficiently manage group memberships. Also, access to enterprise applications and role assignment. User access can be reviewed regularly to make sure only the right people have continued access. Admins who created access reviews can track process as the reviews complete their process. No access rights are changed until the review is finished. When the review is complete, it can be set to manual or auto-apply changes to remove access. Also, the reviews could go with a multi-stage access review process. Microsoft Intra Access reviews support up to 3 review stages, in which multiple types of reviewers engage in determining who still needs access to company resources. Now, apart from that, we want to know and talk about something called Privileged Identity Management. Privileged Identity Management, or PIM in short, is a service in Microsoft Intra that enables you to manage, control, and monitor access to important resources in your organization. These include resources in Microsoft Intra, Azure, and other Microsoft Online services such as Microsoft 365 or Microsoft Intune. PIM mitigates the risk of excessive, unnecessary, or misused access permissions. It requires justification to understand why users want permissions and enforces multi-factor authentication to activate any role. When we talk about PIM, we refer to a just-in-time access, providing privileged access only when needed and not before. Also, we talk about time-bound by assigning start and end date that indicates when a user can access resources. We look for having an approval-based system requiring a specific approval to activate privileges. Making also this access visible, sending notification when privileged rules are activated, and looking for access who are auditable, allowing a full access history to be downloaded. Did you know that Microsoft analyzes trillion signals per day to identify potential threats? And in 2021, Microsoft have blocked more than 25.6 billion Microsoft Intra brute force authentication attacks. These signals come from learning Microsoft has required from their position in organizations with Microsoft Intra ID. Also, the customer space with Microsoft account and in gaming with Xbox. The signals generated by these services are fed to identity protections and then can be used by tools such as conditional access, which uses then to make access decisions. Signals are also fed to security information and event management SIEM tools, such as Sentinel, for further investigation. So, what is identity protection? Identity protection is a tool that allows organizations to accomplish 3 key tasks. First, automate the detection and remediation of identity-based risks. Second, investigate risk using data in the portal. And finally, export risk detection data to third-party utilities for further analysis. During the detection phase, it calculates the sign-in risk and the user risk. In the sign-in risk, we look into the probability that it wasn't performed by the user. On the other hand, for the user risk, we look into the probability that their identity has been compromised. Then, in the investigation risks phase, identity protection provides organizations with 4 reports that they can use to investigate identity risks in their environment. After this phase, we have the remediate phase. In this phase, organizations can enable automated remediation using their risk policies, or manual remediation, where an administrator must manually review the identity risks in the report. You can finally move to the export phase, where data from identity protection can be exported to other tools for archive, further investigation, and correlation. Let's move to our last slide for this lesson, talking about permissions management. Microsoft Intra Permissions Management is cloud infrastructure entitlement management product that provides comprehensive visibility and control over permissions for any identity and any resources in Microsoft Azure, Amazon Web Service, and Google Cloud Platform. Permissions management allows customers to address 3 key use cases: discover, remediate, and monitor. In the discover use case, customers can assess permission risks by evaluating the gap between permissions granted and permission used. Then, in the remediate use case, customers can right-size permissions based on usage, grant new permissions also on demand. In the monitor use case, customers can detect anomalous activities with machine learning-powered alerts and generate detailed forensic report. In this session, we explored the services and identity types of Microsoft Intra ID, along with the capabilities of Microsoft Intra ID, including authentications, access management, and identity protection and governance. This concludes session 2. We will take a quick 10-minute break and start back with session 3, talking about the capabilities of Microsoft Security Solutions. See you shortly. Welcome back from break. I hope you have had the chance to step away from the computer for a minute. I know a day of virtual training can be a lot. And we are almost done. But I want to make sure you are good and ready to go for the next session. So with this session, session 3, we are going to go over some of the different security solutions in Azure, especially. In this session, we have 2 lessons that we will look at. In first lesson, we will describe core infrastructure security services in Azure. And in lesson 2, I will walk you through the security management capabilities of Azure. Let's start with lesson 1 and start talking about core infrastructure security services in Azure. Now, after completing this lesson, you should be able to look at different security capabilities of Azure and how you can protect your network. You will be familiar with network security services in Azure like DDoS, NSG, and Firewall, and other services like Bastion and Key Vault. Now let's start talking about one of the tools that we have available in Azure to protect your network environment. Earlier, we spoke about defense in depth, and we spoke about distributed denial of service attack and how to protect it. The aim of distributed denial of service attack is to overwhelm the resource on your application and servers, making them unresponsive or slow for the legitimate users. A DDoS attack will usually target any public-facing endpoint that can be accessed through the internet. The 3 most frequent types of DDoS are volumetric attacks, and these flood the network with seemingly legitimate traffic, overwhelming the available bandwidth. We have also protocol attacks, and these focus on exhausting the server resources with false protocol requests that exploit weakness in layer 3 and also in layer 4 protocols of the OZ layer. The 3rd type of attack is resource, and this targets the application layer. This attack targets web application packets, so it's going to focus in the 7th layer of the OZ layers. Well, inside Azure, you have an integrated service to help you protect your organization against these malicious attacks. The way it works is that Azure monitors the traffic coming into your network. Once it recognizes an attacker, it automatically blocks his traffic, but leaves your network open to legitimated traffic, so there is no interruption of service for your users. In Azure, we provide you with an included free DDoS protection service and 2 paid tiers, DDoS network protection and DDoS IP protection. Both SKU had enhanced mitigation features to defend against DDoS attackers. The DDoS network protection protects your specific Azure resources in a virtual network, while the DDoS IP protection is a pay-per-protected IP model. Now you wonder why consider adding a DDoS protection service if services running on Azure are inherently protected by the default infrastructure level DDoS protection. Good question. The reason is because the protection that safeguards the infrastructure has much higher threshold than most applications have the capacity to handle, and doesn't provide telemetry or alerting. So while traffic volume may be perceived as harmless by the platform, it can be devastating to the application. By onboarding to Azure DDoS protection service, the application gets dedicated monitoring to detect attacks and application-specific thresholds. A service will be protected with a profile that is tuned to its expected traffic volume, providing a much entire defense against DDoS attacks. Now moving to Azure Firewall. I want to take a minute and go back to the first session, where we discussed defense in depth. The aim of Azure Firewall is to protect your perimeter and stop all attacks. There, before they reach your network, they will be stopped. Azure Firewall is a scalable, high available solution that you can adjust to meet the needs of your traffic. Azure Firewall uses IP address, ports, protocols for filtering and has already a built-in threat intelligence detection that can be automatically blocking known malicious IP addresses. In addition, Azure Firewall has the ability to do outbound SNAT and inbound DNAT to communicate with internet resources. Now, SNAT is source NATing, network address translation, and DNAT is destination NATing, which is a destination network address translation. Azure Firewall integrates seamlessly into Azure Monitor, so you have access to all the logs where you can dig into different traffic as needed. Now let's look into the next service, web application. Web applications are increasingly targeted by malicious attacks that exploit commonly known vulnerabilities like SQL injection and cross-site scripting. Preventing such attacks in application code is really challenging. It can require rigorous maintenance, patching, monitoring of your solution. Web Application Firewall, or WAF, provides centralized protection of your web applications from common exploits and vulnerabilities. A centralized WAF helps to make security management simpler, improves also the response time to security threats. In addition, it allows patching known vulnerabilities in one place instead of securing each web application apart. A WAF also gives application administrators better assurance of protection against threats and intrusions. Remember defense in depth, right? We have seen it in session 1. What we covered until now was the protection of the perimeter of the network. Let's now dive inside your network and get closer to your workload. The best practice in this area is to segment your network. Segmentation is about dividing something into smaller pieces. An organization, for example, will typically consist of smaller business groups such as human resources, sales, customer services, and more. In an office environment, it's common to see each business group have their own dedicated office space, while members of the same group share an office. This enables members of the same business group to collaborate while maintaining separation from other groups to the address of confidentiality requirement of each business. The same concept applies with corporate IT networks. With network segmentation, you will be able to isolate resources and apply governance policies set by the organization. Now let's understand what is Azure Virtual Network first. VNet, or Azure Virtual Network, is the fundamental building block of your organization's private network in Azure. VNet is similar to a traditional network that you would operate in your own data center, but brings with it additional benefit of Azure infrastructure, such as scalability, availability, and isolation. Azure VNets enables organizations to segment their network. Organizations can create multiple VNets per region, per subscription, and multiple smaller networks, we call subnets, can be created within each VNet. VNets provide network-level containment of resources with by default no traffic allowed across VNets or inbound to the VNet. Communication needs to be explicitly provisioned. This enables more control over how Azure resources in a VNet communicate with other Azure resources and the internet and also the on-prem networks. Now, which service will we use to allow or block traffic within these VNets? Network security groups, NSGs, let you allow or deny network traffic to and from Azure resources that exist in your Azure virtual network, for example, a virtual machine. An NSG consists of rules that defines how the traffic is filtered. You can associate 0 or 1 network security group to each virtual network, subnet, and network interface in a virtual machine. The same network security group, however, can be associated to as many different subnets and network interfaces as you choose. An NSG is made up of inbound and outbound security rules. NSG security rules are evaluated by priority using 5 information points: source, source port, destination, destination port, and protocol, to either allow or deny the traffic. As a guideline, you shouldn't create 2 security rules with the same priority and direction. Now, let's move to the portal and see how to create these NSGs. So we logged in into the portal.azure.com. I logged in using my credentials to my subscription demo Contoso. Now I'm going to access to resource group. So I'm going to write in here resource group. Then I'm going to connect to my resource group lab SC900. And in this resource group, I have a VM that exists in a VNet and in a subnet, and it doesn't have any network security group. So I'm going to create a network security group, and I'm going to write NSG in here. So I'm going to look for it, write in network security group, and then I'm going to create my network security group. It selected the resource group lab SC900 for me, and then I'm going to name it NSG and SC900. I select a region. For this case, selected East US, and then I review and create this network security group. Now it's going to deploy my NSG for me. And I could go to my NSG. And once I logged in, I see that I have inbound security rules. I have outbound security rules. They are put in order of priority. And the order is the higher the number, the lower the priority. So I have 3 by default inbound security rules and 3 by default outbound security rules that I cannot delete or modify. Then I could come from here to add an inbound security rule. I could also from here select to add an outbound security rule. And here I could, with interface, network interface or subnet, I could associate this network security group to a subnet or to a network interface. So let's assume that we are going to create a rule, an inbound rule. So I came from here to add a rule. I put source to any, the port to star, which means any port. I put also destination to any, and I'm going to select a service which is RDP. That's going to help me to log in to my VM after I will be able to associate each NSG to the subnets of the VM. Once done, I give it priority. We talked about the importance of priority, and the action is allowing traffic coming from the RDP. Then it's going to provide it a name, allow any RDP inbound traffic. Once I added this to my network security group, I came here to the subnet. I click to associate. I'm going to select the virtual network, which is the virtual network for my VM, which is in the resource group lab SC900. I select the subnet, which is the default, and then I apply it. Once it's applied, I will be able to RDP into my VM and access to my VM. Now that you have got your firewalls and network security group in place, and that you feel pretty good about your defense against external threats to your VMs, you want maybe to access to the VM to do some tasks. If you are thinking of using remote desktop protocol and SSH ports, you have just exposed yourself to different kinds of attack. Azure Bastion is a service you deploy that lets you connect to a virtual machine using your browser and Azure portal. The Azure Bastion service is a fully platform managed PaaS service that you provision inside your virtual network. Azure Bastion provides secure and seamless RDP and SSH connectivity to your virtual machines directly from the Azure portal using Transport Layer Security, TLS. When you connect via Azure Bastion, your virtual machines don't need a public IP address, agent, or special client software. That will be managed in the Bastion side. Let's move to the next service. Azure provides you with a solution where you can keep your valuable items such as passwords, API keys, encryption keys, and certificates. Azure Key Vault is a cloud service for securely storing and accessing secrets. A secret is anything that you want to tightly control access to, such as API keys, password, certificates, or cryptographic keys. When you use Key Vault to store and manage these secrets and keys, instead of putting them in your application code or configuration files, this way you can avoid exposing them to unauthorized parties or compromising your security. But how do you access your secrets and keys in Key Vault? Well, you need to authenticate yourself first using Microsoft Entra ID. Once you are authenticated, you need to be authorized to perform certain operations on your secrets and keys. You can use either Azure Airbag or Key Vault Access Policy to grant or deny permissions to your secrets and keys. For example, you can allow some users to read your secrets but not write or delete them. Another benefit of using Azure Key Vault is that you can monitor who accesses your secrets and keys and what they do with them. Azure Key Vault has two service tiers, Standard, which encrypts with a software key, and the Premium that includes Hardware Security Session, HSM. Now that we have learned a little bit about core infrastructure security services in Azure, let's start with Lesson 2 and describe security management capabilities of Azure. In this lesson, we will talk about Microsoft Defender for Cloud and Azure policies. Then we move talking about cloud security posture management and cloud workload protection platform. And finally, we will talk about development security operations. Let's start with Microsoft Defender for Cloud. Microsoft Defender for Cloud is a cloud-native application protection platform, CNAPP, with a set of security measures and practices designed to protect cloud-based applications from various cyber threats and vulnerabilities. Defender for Cloud combines the capabilities of a development security operation, DevSecOps, and cloud security posture management, CSPM, solutions. In addition, a cloud workload protection platform, CWPP. With DevSecOps, Defender for Cloud helps you to incorporate good security practices early during the software development process. You can protect your code management environments and your code pipelines and get insights into your development environment security posture from a single location. While with CSPM, you assess your systems and automatically alert security staff in your IT department when a vulnerability is found. CSPM uses tools and services in your cloud environment to monitor and prioritize security enhancement and features so admins can take to secure the environment. Finally, Cloud Workload Protection Platform Surface workload-specific recommendation that leads you to the right security control to protect your workloads. When your environment is threatened, security alerts right away indicate the nature and severity of the threat so you can plan your response. Each of these areas is covered in more detail throughout the rest of this session. But first, it's important to start with an understanding of the policies and security initiative that Microsoft Defender for Clouds applies in the course of making recommendations. Policies and initiatives are a foundational component of Microsoft Defender for Cloud and how Defender for Cloud assesses security posture and compliance. Now, what are policies and initiatives? Another policy definition created in Azure Policy is a rule about specific security condition that you want controlled. Azure Policy supports built-in definition, but you can also create your own custom policy definitions. For example, a policy could be to allow only the creation of resource on a specific region. Now, security initiative is a collection of Azure policy definitions or rules grouped together toward a specific goal or purpose. Microsoft Defender for Cloud uses a default security initiative called the Microsoft Cloud Security Benchmark, MCSB. This initiative evaluates your hybrid cloud environment against a set of controls and best practices and shows your compliance status in the regulatory compliance dashboard. You can also create your own Defender for Cloud initiatives in Azure Policy to customize your security assessment. Microsoft Cloud Security Benchmark is a Microsoft authored set of guidelines for security and compliance that provides best practices and recommendations to help improve the security of workloads, data, and services on Azure and your multi-cloud environment. It builds on the control from the Center of Internet Security and the National Institute of Standards and Technology, with a focus on cloud-centric security. Defender for Cloud continually assesses your cross-cloud resources for security issues. It then aggregates all the findings into a single score so that you can tell at a glance your current security situation. The higher the score, the lower the identified risk level. All Defender for Cloud customers automatically gain access to the security score when they enable Defender for Cloud. Microsoft Cloud Security Benchmark is automatically applied to your environments and generated all the built-in recommendations that are part of this default initiative. In addition, Microsoft Defender for Cloud provides hardening recommendations based on any identified security misconfigurations and weaknesses. Recommendations are grouped into security controls. Each control is a logical group of related security recommendations and reflects your vulnerable attacks surfaces. Your score only improves when you remediate all of the recommendations for a single resource within a control. Use these security recommendations to strengthen the security posture of your organizations on Azure, hybrid, and also the multi-cloud resources. A pillar of cloud security is cloud workload protection. Through cloud workload protection capabilities, Microsoft Defender for Cloud is able to detect and resolve threats to resources, workloads, and services. Cloud workload protections are delivered through integrated Microsoft Defender planes, specific of the type of resource in your subscription, and provide enhanced security features for your workloads. First, it provides you with comprehensive endpoint detection and response within Microsoft Defender for servers. We have also vulnerability scanning for virtual machines, container registries, and SQL resources. You can activate also your multi-cloud security by connecting your accounts from Amazon Web Services and Google Cloud Platform to protect resources and workloads on those platforms. For your on-prem resources, you can activate hybrid security to get unified view of security across all of your on-prem and cloud workloads. Finally, with the Access and Application Controls feature, you can block malware and other unwanted applications by applying machine learning-powered recommendations adapted to your specific workloads to create a allow list and a block list. Defender for DevOps is a service available in Defender for Cloud. Empowers security teams to manage DevOps security across multi-pipeline environments. Defender for DevOps uses a central console to empower security teams with the ability to protect applications and resources from code to cloud across multi-pipeline environments, such as GitHub and Azure DevOps and others. Findings from Defender for DevOps can then be correlated with other contextual cloud security insights to prioritize remediation in code. There are three key capabilities in Defender for DevOps. First, it provides unified visibility into DevOps security posture. Second, it strengthens cloud resource configuration throughout the development lifecycle. This could be done by enabling security of infrastructure as a code templates used to define and deploy the infrastructure quickly and in reliable manner. Finally, it prioritizes remediation of critical issues in code. For example, security admins can help developers prioritize critical code fixes with pull request annotations and assign developer ownership by targeting custom workload feeding directly into the tools developers are using. Now, let's move to the portal and have a look at Microsoft Defender for Cloud. Now I have to log in to portal.azure.com. So I click on portal.azure.com. I put then my credentials. Once the portal is opened, I'm going to look for Microsoft Defender for Cloud in the search bar. Otherwise, I can also find it in the shortcut from here and access it directly. My Microsoft Defender for Cloud is showing that I have 2 subscriptions, 4 AWS accounts. I have different assessed resource, active recommendation. I could see security alerts and also security posture, which is showing me the unassigned recommendation. It is showing me also the secure score, and I see that it's 34%, and it includes Azure, AWS, and GCP, and I could see the different score that I have. I have also the regulatory compliance. I could see workload protections. I could also see the inventory, and in addition, I have from the left menu, I could access to different features. Now I access to the environment settings. Once I access the environment settings, I could expand all, see all my subscriptions. I have Contoso Hotel. I could see also the different AWS project and GCP. Let's select Cyber subscription. And now it's showing me the Cloud Security Posture Management. I could see that I have by default the foundational CSPM. I have also Defender CSPM that is implemented, which is payable and is applied to 340 resources. I could see the cloud workload protection and all the workload. I could access from here to the security policy, and I could see the default initiative that is implemented to my subscription management group. I have also industry and regulatory standard that I could see, where I have the list and I have my Microsoft Cloud Security Benchmark. And I could, if I want to, add other custom initiatives to my subscription. Let's get back. Now let's get back. I could go to recommendations, and I have the inventory. I have the overview where I have seen all my assessment that take me back to the inventory, where I could access it also from this menu. I could see all the resources that exist. I could see the unhealthy resources, the unmonitored resources, and also the unregistered subscriptions. Now here's a group of VMs. I could see the recommendations existing to these VMs. Let's assume we select this VM. I could see all the recommendations in order from high to medium. I could access to one of the recommendation, and it's going to give me the description the remediation steps one by one to implement it, to fix this score. Now, when I access another recommendation, for example, here a virtual machine should be protected with network security groups. Here I have the full description, and I have longer remediation steps explaining how to add NSGs. Now let me take you to recommendations, and I have the secure score and all the recommendation to improve it. So I see there is a green and red explaining that I need to improve more my score. Once I select, for example, secure management port, I select one of them that is regarding that the port of VM should be closed. I could see the description and the recommendation steps one by one that I should implement to improve that score. Now, apart from that, in my security posture, I could look at the different environments, and I could also go to regulatory compliance, where I could see all the regulatory compliance implemented, and we could see our dearest friend Microsoft Cloud Security Benchmark. We have other recommendation also that I could select or see other regulatory compliance existing. Now let's assume we selected the NS network security, and I could see that automated assessment for Azure, for AWS, and the resource compliance statute is all green, which means it's applied everywhere. Now let's select one that has red signals, and I could see that I have different recommendations, and I have the quick fix that exists in some recommendation, not only the manual as we have seen previously. Now let's move to workload protections, and in the workload protection I have the Defender for Cloud coverage for my VMs, containers, databases, servers, etc. And I could see security alerts with different colors, high, medium, and low. Well, everyone, that brings us to the end of session 3 and our content for this first part. Let's recap what we have seen so far. In session 1, we talked about the concept of security, compliance, and identity. Then, in session 2, we explored the service and identity types of Microsoft Entra ID, along with the capabilities of Microsoft Entra ID, including authentication, access management, and identity protection and governance. Finally, in session 3, we described core infrastructure security services in Azure, and we learned the security management capabilities of Azure. Well, that's all I got for today. Be sure to join us for part 2, where we'll continue with session 4 and session 5. And since we have a solid foundation built with some of the concepts we have discussed today, we're going to start by discovering 2 services, Microsoft Sentinel and Microsoft Defender XDR. But if you can't wait, you can get a preview of upcoming content as well as a review of today's topics on the free learning path at aka.ms/SC900. If you are planning to take the exam, I don't want you to worry too much. You will not have to implement anything in the portal. Instead, I want you to focus more on identifying and describing the concept. Thank you. Goodbye.